This video is going to be kind of a quicker overview of solving equations. So if you're learning to solve equations for the very first time, I would recommend the video that I'm going to link in the description on YouTube. Otherwise, we're going to do a quick overview at the beginning, and then we're just going to dive into hard equations relatively quick. So sitting down to an equation, this equal sign means that the statements on each side are equal to each other, right? X minus 3 is equal to 2. So as we work through this equation, anything that we do on one side of the equation, we have to also do on the other side of the equation. So I want to work backwards through this problem, right? What I have right now is x, some number. When I took away 3 from it, I ended up with 2. It was equal to 2 at the end. So you probably know what this is without doing anything. But just for the example, we're going to work through it like we would if we didn't know. So we had some number, we took away 3, we got 2. We want to go back in time to when we just had that number, that x, and our goal is to have an equation that has x equals at the end, because that'll tell us what that x was. So before I subtracted that 3, if I want to undo that, I'm just going to do the opposite of that. I'm going to add 3, and if I do that on this side of the equation, I absolutely must do it on this side of the equation as well. So negative 3 and plus 3 cancel right out, and I've got x equals, and 2 plus 3 is 5. We're all done. We've got that x equals form. Here's our equation. So here we are. Same idea. We want to undo things, making sure we're doing it on both sides of the equation. I had some number. It got multiplied by 3 and divided by 5 and then subtracted by 3. And the resulting thing was 6. I want to go backwards through that and undo it. Now, if you remember PEMDAS, when we were simplifying an expression, we go from left to right, or we start inside the parentheses, then we do the exponents, we do multiplying and dividing, and then we do adding and subtracting. If you're trying to undo to get back to the beginning, I recommend doing PEMDAS backwards. It's not strictly necessary that you do it that way, but it is just going to keep everything simpler, make your life easier. So let's undo this subtracting first and add 3 on both sides of the equation. Canceling, we've got 9. Here's 3x over 5. Now, you could think of this as 3/5 and cancel that fraction by multiplying by the reciprocal. But I can also just think of this as 2 steps. So I could get rid of this divide by 5 by multiplying by 5 on both sides. And then I can get rid of this times 3 by dividing by 3 on both sides. And I'm down to x equals 15. Now, just to show you why that's easier than starting with undoing, multiplying, or dividing, if I started by saying, I want to get rid of that divide by 5, you can. You can multiply by 5 on both sides, but you have to multiply this whole equation by 5, not just part of it. So that's just often what people forget, right? So they do this probably. They do this canceling probably, but they might forget that the 5 is also getting multiplied with that 3. If you don't forget, listen, this is going to be an easy, you can solve it this way. You'll get right down to the same answer like we had before. It's just that people have a tendency to forget that distributive detail. So if you start with undoing, adding, and subtracting, you don't have to worry as much about remembering those details. When I've got x on both sides of the equation, want to move all my x's to one side. So I'm going to move this 5x. Didn't have to. Could have moved the 7x. It's all good. I'm going to get my, almost lost that negative. Don't lose that negative. I'm going to get all of my constants to one side. And then I'm going to divide by 2 to solve for x. A negative divided by a positive is going to stay negative. All right. Now, this guy here, you've got choices. I personally would just get rid of this divide by 6. Remember that line means divide. I would just multiply everything by 6 to get rid of that right now. But, it's up to you. You don't have to do that first. But if I do that, I multiply the whole equation by 6, it's going to cancel this 6 here. And over here, it has to also, again, go to everything in the equation. And now we're just trying to get x on one side. All of my x's on one side, that is. Moving my constants around. So remember, when you are adding and subtracting things across the equal sign, you just put it with its like term, right? I move my x's with my x's. When I'm multiplying or dividing, I have to hit everything, no matter what. Like that's what happens with multiplying and dividing. Otherwise, if I don't multiply the whole thing, I have now changed the balance of the equation. So here we are. We had that negative divided by negative. X equals positive 3. Okay, options here. You could distribute this 4 first if you wanted. 4x minus 8 equals 20. Or you could divide by 4 first if you wanted. 20 divided by 4 is 5. Both of these equations are going to get you to the same answer. Just a reminder that the options are open. Now, look at this messy guy. Let's do some combining like terms. I have these x's on the same side of the equals, so I can just combine them. I don't need to do the opposite operation, right? I don't need to add 4x because these are on the same side of the equal sign. They're in an expression together. They just get combined. So I have 7x minus 4x is 3x. And I have plus 5 plus 3, that's going to be 8. Over here, I still have 3x minus 7. Oh my, can you see what's going to happen? I'm going to get all of my x's onto the same side, but oh my gosh, no, I'm not. They're all disappearing. Okay, what happens when I get to an equation like this? Negative 7 equals 8, which is clearly untrue and is never going to be true. This is never true, and x didn't even really enter into it. All of the x's canceled out. So what we're going to say is no solution. There is nothing you could put in for x that would make this true because negative 7 is never equal to 8. Yeah? Now, similar equations, slightly different. We're going to, again, combine like terms. Plus 4 plus 3. And you can see what changed. Now, right now, I have my two statements are exactly equal to each other. Even if I try to combine my x's, we're going to have 7 equals 7. When is that true? This is always true. There is no x that we could put in that would not make this true, right? That would make it false. So no matter what x is, this is always true. So we can say for this, all real solutions. We can say another way to just write that same thing is a little fancy r like this. You could write in interval notation that x can go from negative infinity to infinity because it can be anything. These are always true. There's nothing you could put in for x that would break this.